Hello and welcome back. So hopefully you just watched the first video introducing shading in an area horizontally in terms of Y. So this next example should be on the back of that page you just finished, and it's actually pretty similar, so feel free at any point to pause this and try to do it on your own. But we're going to have to talk about, so it's the area of the region bounded by these two, I shouldn't say functions because they're not functions, two equations, and they don't give you the picture, so you would have to know what this looks like. And I would not suggest trying to get that in terms of y when it's squared. We kind of need to know in our heads if it's y squared, it's a horizontal quadratic. So I'm going to come over to the side first, and I would suggest writing this down so you have it in your notes, that anytime you have, it's kind of like the parent function is x equals y squared, and again I shouldn't say function, but the parent graph is, if it's just x equals y squared, that would be a horizontal quadratic going to the right with a vertex at the origin. So if we think about our transformations, we know a negative, now it's negative in front of that y squared, it would reflect it, and it's going to actually reflect it across the y-axis. So that negative would flip it, and then what does that 3 do? Well, we know normally a 3, if you think about moving it over to this side with the x, it would be minus 3. And we know when it's x minus 3, it shifts it to the right. So it's kind of backwards now. But that 3 is actually going to shift this to the right. I'm trying to find a good video if you wanted to break this down, but I can't find one online. I can't talk. If I find one before I post this, I will definitely link it also. But so we know if it's just x equals negative y squared, it would reflect it. And then because of this 3, that's actually going to shift that reflected 3 to the right. It's backwards than your normal transformations. So that is going to be what this graph looks like. And now this graph, to know that one, I would think about, since it's not being squared, I would think about getting y alone just to get the graph, not to do anything else. But we know if we move this 1 over, it'd be y equals x minus 1, so we know it's just a linear line with a y-intercept of negative 1. So let's put those on a graph together. And now really before I draw my graph, it might help to get my intersection points just like we did before, so I know I'm drawing it to scale. But if you want to go ahead and sketch it and then just put the intersection points first, or find your intersection, whatever makes more sense to you, but I'm going to do the intersection points first. So what you still take what this equals and this equals and set them equal, right? It's just going to be in terms of y. Everything should be in terms of y now. So 3 minus y squared equals y plus 1. And so now to solve this, again we see a y squared, so we're going to have to factor, and I want that squared term to be positive, so I'm going to move everything to the right. So add y squared. We're left with 3 equals y squared plus y plus 1. Move over the 3. And we, not y, 0 equals y squared plus y minus 2. Let's go ahead and factor this. It would be what multiplies to get negative 2 and adds to get positive 1. It would be a positive 2 and a negative 1. So that makes your intersections at y equals negative 2 and y equals positive 1. Notice those are y, not x. So it's going to intersect when y is down 2 and y is up 1. If you want to get the actual ordered pair just to help you graph, you're not going to use it for anything else, but if to help you graph, you're more than welcome to. So let's see, I'm going to try to color code this. This quadratic, we already said we know it's going to look like this. So it's shifted over 3, and then opening up to the left. And we know this is going to look like a linear line with a y-intercept of negative 1. Okay, so if we can see the area shaded would be, or the area bounded, I should say, would be this area. So how am I going to shade that in? Should I draw vertical lines or horizontal lines? Well, let's think. I'm not going to actually draw it, but if I do vertical, it's going to switch over here on this far right side, right? You're not going to be using that purple line at all, so let's not do that, especially since it was in terms of x equals. You should have already known. You should probably do horizontal lines to shade it in. So how do we know those are boundaries for that area? Is we know this intersection point. Where do they intersect at? This y value down here, because we don't really need the x value, was -2. And this intersection point up here was at y equals 1 from over here. If you did get the actual ordered pair, it should line up, but I didn't get it just because I don't want us to use it in our integral. So what does that mean? Is you started drawing horizontal lines at as low as -2 and you kept drawing them up to 1. So when you create your integral to know the area, -2 is your A, 1 is your B, and you're going to go right minus left, right? We're using this formula because we drew horizontal lines and our function was in terms of y. It's x equals. So right was the red quadratic, which was 3 minus y squared. And then you do minus the left, which was the purple line. Sorry, is this crooked? Which was y plus 1. Always put it in parentheses because you're subtracting it. And then you close it with dy with respect to y. Okay, so you should probably be able to clean that up and take the antiderivative and do f of b minus f of a. So I would try that on your own starting now, but I'll go ahead and work out this one. So we have the integral from -2 to 1 of, I'm going to put this in descending order, so I have -y squared. If I distribute this negative, that would be minus y, and then that's -1 now, and then you combine it with this positive 3, so that becomes 3 minus 1 is 2. Hopefully we all knew that fact by now. And now we can take the antiderivatives. So we got, if we add 1 and divide the coefficient, that becomes, let me do, -1/3 y cubed, add 1 to the exponent and divide the coefficient, minus 1/2 y squared, and that becomes plus 2y. And we're going to plug in our boundaries, -2 and 1. So now we're ready to do f of b minus f of a. So we have -1/3 times 1 cubed minus 1/2 times 1 squared plus 2 times 1 minus, put your f of a in parentheses, -1/3 times -2 cubed minus 1/2 times -2 squared and plus 2 times -2. So I'm going to have you try to simplify that. And I'm just going to go ahead and give you all the answer to that, but make sure you clean this up, watch your negatives, distribute this minus sign outside of this parenthesis set, and see if you can get the answer. And I'm about to say it now, so pause it if you haven't done it on your own. And you should get 9/2, or if you change that to a decimal, 4.5. Okay, so if you're struggling to ever get those answers, let me know, and I can post a video actually doing the algebra if anyone's getting stuck, but you'll have to make sure you're communicating with me and letting me know. Okay, so I'm trying to decide. I think I'll just do shorter videos. I'm going to go ahead and stop this one, and I'll do the next example on another video.